Okay. Probably can put that out on YouTube and everything else. Okay, so couple of things. I've got everything handed in that you all have graded, and kudos to my first block class because you guys are the only ones so far that have everything turned in. There was one kind of like odd wheel that took a while to get everything done, but at least literally, you guys are the only class that has everything turned in so far. So I'll email that back to you. I've got it graded. I just have to send it back out on that. So here's how this is going to play out. So today we've got like this last big kind of cumulative assignment over all this math toolkit stuff, dimensional analysis, significant figures, all this good stuff. Then there's still some gray area in terms of how I see this playing out. So we got this tomorrow. We're going to go over that assignment, so you guys will watch that on YouTube or Zoom in or whatever you want to do. Then on Monday, you're going to have your first short test over this math toolkit stuff. Okay, and I've got a list of topics. So tomorrow, after we go over this assignment that I'm giving you all today, right? And with this assignment, if you all want to, okay, there's a couple of ways you can play this. The assignment I'm going to give you today, we're going to go over tomorrow, okay, which is going to be Friday, right? Your assessment is going to be on Monday. For those of you that are on the other group, you guys are going to take your assessment on Tuesday. So what's going to happen, because I'm just still a bit of a control freak and I want you all to take your tests in this room. So what will happen on Monday then, you guys here will be taking the test. Those of you that are learning remotely, I'm going to have a lecture dumped out on YouTube that on Monday, if you're not here, you're going to watch that. So on Tuesday then, they're going to be taking the test, and you guys are going to be watching that video on velocity. It's going to be an introduction to velocity, okay? So that's how it's going to play out. So with this assignment that I'm going to give you today, because the test is going to be on Monday, I don't care how you want to play this. If you get done with that and you want to send that in to me right away, I'll get it graded and I'll get it sent back to you so you have it to prepare for the test. Okay? If you just want to wait and hand it in on the day of the test and use it like as a study guide and then just wait and then hand it in, that's up to you. Okay? I'm just going to need it. So you guys that are watching, that are remote learners, you already have this. You already have that assignment. We're going to go over it in class tomorrow. You guys will take your assessment on Tuesday. Again, you guys can decide, do I hand it in today? Do I hand it in tomorrow when it's due? Or do you want to wait and hand it in Tuesday when you take the test? That's purely up to you guys. Okay? Some people like to hand it in and get it graded and everything else. I mean, we're going to spend a lot of time tomorrow going over that because that's basically, to a certain extent, what the test is going to be. So tomorrow, I'm going to spend a lot of time going over that assignment because of the fact that, this is kind of the cumulative thing that we've done. Okay. Also, the deadline for enrolling for this, if you want to take this class from WSU dual credit, the deadline is midnight on the 21st of September, which is, I think, next Tuesday. Okay? So if you're going to do that, okay, and I think I've already gotten some emails, I think some of you have already started that process. Do not wait until the last minute to start that, because it's a bit of a process. You've got to fill out some stuff, you've got to, set up the payment, all that good stuff. It's a great opportunity. It really is. I mean, if you look at what the cost of tuition is, I mean, it's a bargain, okay? So if you're thinking about doing that, do not wait until the last minute to say, oh, it's 11:30 on Tuesday night and midnight is the deadline. Oh, I guess I'll start the process. No, it's going to be a train wreck. Start it this weekend. I've sent you that email. If you have any questions at all, get a hold of Jordan. She is of great help. She will be able to take you through that. There's some videos that are there. So there's that. Okay. All right, so let's talk about that assignment 1-1, which you all should have. Anything, any particular ones you want me to go over?
For 14?
14? With trig functions?
Yeah.
That's 15.
Yeah, let's do 14 and 15 actually.
Okay. All right. So you got 1.20 times 10 to the third kilometers per 1 hour. Okay, so this is number 14. Okay? So I promise you, if you get done with that assessment and you haven't done a conversion from kilometers per hour into meters per second, you've done something wrong. Okay, I promise you this is going to be something that you have to be able to do without giving it a second thought. So what you were given, you've got this number, 1.20 times 10 to the third kilometers per hour. That's how far this thing is going to travel in 1 hour. So put that hour down here. Don't put that hour up here. Stack this thing. Put 1.20 times 10 to the third kilometers per 1 hour. Now, written like this in scientific notation, how many significant digits are there? 3, because everything in scientific notation is significant. Okay? Now, let me show you the historical perspective on why you do significant digits. So, this was given to me by one of my uncles. And this is how math used to be done. Anybody know what this is? It's called a slide rule. Okay? So, slide rules are amazing. This is what actually got us to the moon. If you ever watch the movie Apollo 13, and they're talking about doing some calculations, you'll see guys using this, okay? And this is fairly complex, like it has trig functions, it has logs, it has a whole bunch of different stuff. This used to be the calculator. It used to be, not that, probably 40 years ago, if you were going into engineering, in high school, you actually would take a class on using slide rules, okay? This was a class. So, the reason for scientific notation was that if you were to multiply numbers together, this is like 12,000 kilometers per hour. You can't do 12,000 on a slide rule, but what you can do is you can do 1.2. So, slide rules were designed for a numeric system where you have just one number to the left of the decimal place, and then you would deal with the exponents later on. So that was the whole basis of scientific notation. So what you would do is you could this middle tab slides, and then you can also slide this. So you can multiply, divide, add, subtract, you can do all sorts of cool stuff with this. You get bored, do a YouTube video, like how do you use the slide rule? And there's actually YouTube videos on how you can use this. So this method right here is what actually did most of the computations that got us to the moon. And so it's so it is ancient, but it isn't that ancient. So it isn't like, wow, this came from they found this in the Great Pyramids of Giza. No, okay? This relatively old style, but that was the basis of it. So, you got this is how many kilometers, it could be 120, it could be 83, whatever this is. Now, down here, and work this the same way every time. 1 kilometer is 1,000 meters, okay? So if I stop right now, I have meters per hour. Okay, that's not what I want, but if I did nothing else, I'd have meters per hour. So then, you know that 1 hour is 3,600 seconds. Now, typically if you screw this up, you're going to put this as 360, because I don't know if you have flashbacks to a circle and you think, oh, a degree is one circle is like 360 degrees and I don't know. If you screw this up, you put this as 360 and not 3,600. So here's the beauty of this process, is that you can lop off these zeros, okay? So basically, you're gonna multiply by 10, and then you're gonna divide by 36. Okay? It's the same process every time. The only thing that changes is this number up here. So when you get done, your answer should be about 333 meters per second. Okay? Now, and that's going to be important because that's kind of the basis of the lesson that we're going to talk about today. So, the beauty of physics is that you can look at your answers and a lot of times ask yourself, hey, did these make sense? So, speed of sound is pretty fast. As a matter of fact, it wasn't really until early 1960s before the United States even developed a plane that could break the sound barrier. It was a guy by the name of Chuck Yeager. And we actually kept that a national defense secret for a long time that we broke the sound barrier because people didn't think planes could fly faster than that because it's like a barrier. So if you ever get a calculated velocity faster than the speed of sound, ask yourself, wow, does this seem reasonable? Okay? So if you've got Timmy riding his bike down a hill, and I say, hey, what's his velocity when Timmy gets to the bottom of the hill? And you get like 500 meters per second? No, okay, you have done something horribly wrong. Okay? Horribly wrong. No.
Good for Timmy.
Good for Timmy. Timmy broke right through the speed limit. Fantastic.
He's breaking records.
Yeah, there you go. Timmy, good for you. Way to go. Okay, no. All right, so literally, multiply by 10, divide by 36. The only thing that you change is the number that goes up here. Okay, because everything else always stays the same. And like I said, when you get done with that test on Monday, if you haven't done a conversion of kilometers per hour to meters per second, you've done something wrong. Okay? All right, now on 15, here's the triangle, right? You got the hypotenuse of 2.4 meters. Here's your angle of 30 degrees. You're trying to find this side over here. Well, you only got three trig functions, sine, cosine, and tangent. So you have the angle. You're trying to find the side opposite. You know the hypotenuse. So which trig function are you going to use? Sine. So you got the sine of 30 equals this side over 2.4. Now, what do you know about the hypotenuse? Is that the longest side or the shortest side? Longest. So if you get an answer here bigger than 2.4, you have done something wrong. Okay? So your answer to 15 should be between 1 and 2 meters. If all goes well. Now, on number 12, okay, so let's talk about 12. So here's this meter stick. You're going to stack up all these hydrogen atoms along here like this. Okay? So I've given you the radius of the hydrogen atom. 5.297 or 177 times 10 to the negative 11th. Okay? That's really, 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 really small. Okay? So when you get a problem like this, and let's say you flip out and you go, man, I have no idea how to do this problem. Okay? Just think the process through. At the end of the day, what do you want your answer to be in? What units do you want your answer to be on number 12? Atoms, right? You want atoms. Okay, that's what you want. Well, you've got a length here of 1 meter, right? And you've got this. So somehow or another, I've got to get those meters to drop out of this equation so that I end up with atoms. So think about this. If the radius of that atom had been 0.25 meters, okay? If the radius had been 0.25 meters, well, the diameter then would have been 1/2 meter, okay? So if the diameter of a hydrogen atom is 1/2 meter, and you want an entire length of 1 meter, how many hydrogen atoms would it take? 2, right? So what you did is that you took the length of 1 meter and you divided it by 2 times the radius. Okay? That's what you did. You took 1 meter and you divided it by 1/2, and you got two atoms. So look what happens with the units. So this is meters on top. Once you divide by the radius, excuse me, once you multiply by the radius by 2 to get the diameter, technically that's meters per atom. The meters cancel out, the atoms flip up, there you go. Okay? So you're going to get a big answer because hydrogen atoms are really small. So if all goes well on number 12, you should have an answer of 10 to the 9th. Okay? Something times 10 to the 9th. Make sure on number 6, so let's make sure everybody's cool on number 6. And it's important that you understand the difference between significant digits and precision. They're related, but they're not the same. So what if I gave you this statement? If I said, true or false? It's a true or false question. You got a 50-50 shot, bless you. You got a 50-50 shot. So I said, true or false? You're comparing two different measurements, okay? You're comparing two different measured values. So the measurement that has the most significant digits is the one that will also be the most precise. Okay? So let me say that again. You're comparing two measurements. The measurement that has the most significant digits will also be the one that is most precise. True or false?
True.
True. Everybody cool with true? You should not be cool with true. You should be going, oh no, Mr. Burkamp, that's patently false. Let me show you why. So let's say that I've got 123, 1,230 meters. Okay, so that's my distance, 1,230 meters. There's not a decimal place, so how many significant digits does this have? 3. So this has 3 significant digits. Okay? Now, let's say I gave you this measurement. 7.2 meters. How many significant digits does that have? 2 or 3? 2. This has 2 significant digits, that has 3 significant digits, right? But which one of these measurements is most precise? The 7.2, okay? Because this one knows the whole meter and you're estimating the 10. So this has fewer significant digits, but this is a more precise measurement of distance than this one is. So this is like, how far is it to, the edge of the field? 1,230 meters. It's a ballpark. It's an estimate, okay? We really don't know for certain. Something close. This, we know with a much higher degree of precision. So when you answer number 6, I said, what is the primary consideration in determining how an answer is to be written when adding or subtracting measured values? When you add or subtract, it is the precision of the measurements. It's the least precise place value. When you multiply or divide, it's the least number of significant digits. And you have to keep those two things straight. So when you add or subtract, look for the least precise place value. When you multiply and divide, it's the least number of significant digits. So if I were to multiply these two numbers together, okay, if I were to multiply this by 7.2, my answer can only have 2 significant digits, okay, because that's how many is in there. Okay, anything else you want me to go over on this assignment at all? You have any questions at all? Any nagging questions on any question? Studio audience, do you have anything else you want me to go over? Any questions? Chat now or forever hold your peace. Going once? Going twice? Sold. Okay. All right. So here's what we're going to do. And this is going to require a bit of team effort. Suzanne, I'm going to need you to grab that camera. Riley, I'm going to need you to take that laptop and bring that camera. So what we're going to do is we're going to go out in the hall, okay? And you're going to see your old physics teacher run 10 meters. I'm going to calculate how. Why do you all laugh?
We're just excited. excited.
Well. Okay, see, if a physics teacher dies of heart attack.
No.
No. Maybe just pull a hamstring. Okay. So here's what we're gonna do. We're gonna go out in the hallway and we're gonna measure out 10 meters, okay, all right? And then I'm gonna have a couple of you with stopwatches that are gonna time me how long it takes to run, okay? So that's gonna be the deal. So we need 2 people running stopwatches, okay, all right? And then I'm gonna run, and then we're gonna get an idea of how fast I'm running while we run the 10 meters, okay? So there's gonna be a team effort. So we need somebody, you're gonna take that laptop and just unplug the power cord, and bring that camera, but you gotta keep in mind what they're watching. And then, Suzanne, you bring that camera. So we got to film that for the studio audience that's out on YouTube. And I'm gonna run and try not to die. So, okay, let's go. Woo! Okay. Stop.
I don't know.
Ready? Stop. Okay.
What? Mine?
Berkey, do you run really fast?
No,
Like Speedy, those stopwatches won't even get clicked.
actually, all you guys are gonna see is just a white blur go. So, seriously.
Don't blink, you might miss them.
You might wanna like inhale because the oxygen is.
You hold it.
Sheer
You
fat.
hold it.
Okay, take that, get down that way.
Sorry, I'm trying to get out of your
You
way.
have one job, not be in my way. That's all your job is.
Well, I tried to get out of the way, but then.
Okay, lay down. Okay,
Yep.
all right. So, oh, you gotta hold the camera.
I know, Jalen. Having both jobs.
Riley kept showing me and I didn't want to be in it. So I gave it to you so you could hold so you wouldn't get mad at me.
I'm on him.
Okay.
I'm on him.
So, what we've got, well, now, here's what's going to be important. Okay. So, here's what's going to happen. I'm already going to be moving at warp speed. That wasn't that funny. When I cross that point. Okay, so what we're going to do is we're going to take, and this is going to be important, we're going to take distance and divide it by time to get a velocity. It's a great equation, but it only works when you're moving at a constant speed. So this is why I'm already going to be moving while I run this distance. Because if I start from rest and then speed up and then run at a constant velocity, I'm accelerating part of that time and then I'm running at constant velocity. Okay, so this is why I already have to be moving at full speed when I go by. Okay, so timers. Well, I'm going to do one shot at this. Okay, I am not running this again. Okay, so this is a one-time shot. I'm trusting someone wearing KU stuff. Great.
Don't tell her where you were yesterday, Donna.
Where were you yesterday?
KU.
Oh, Kieran. God. Okay.
Can you see
All right.
him?
Yeah. Hey, we're starting here.
Okay.
We're starting
Bird
here. Okay.
Kip, Bird Kip.
So, like I said, you might want to inhale because all the oxygen is just going to get sucked out of the hole. Okay, are you ready?
Deep breaths, everyone.
Okay.
Look at Belfie. Wait a minute. What you doing? Raina yelled at him.
Wow, that was brutal. Okay, I don't even, camera, you probably never even caught that. Okay, so what did we get for times?
184.
We got the exact same.
Yeah.
Seriously?
Yeah, we're too good.
That's never happened.
Wow!
Do that again so they get
Wow! Okay,
Now we know you're exactly.
okay. Now, do you think this is how they time things at the Olympics?
No.
Yeah, they don't have somebody standing in the middle going, all right, stop. All right, stop. Okay. So, that's, no. So here's the point. We're going to go in and we're going to calculate this velocity. We got some pretty good data, but we don't have phenomenal data. It isn't like we set up lasers on both ends of this for the timing. You guys are sitting there going, start. And you kind of guess when I hit the end of that tape over there. So we got some sketchy data. Not bad, okay? But so when we do this calculation, that's as good as we can get. Okay, so back in we go.
Oh no.
I think you did a pretty good job on that. I didn't yell at them. I was just encouraging you.
That's your encouragement. Oh.
Hi everyone, that's my stomach. Why does it point down? Oh, hey, oh. It's a little lopsided. Wait, I can fix it. Don't worry.
It's not. Oh wait.
Hold on, that cord just has to be. Ellie's in the way.
Sorry.
It's okay.
I'm fixing your other camera. Still a little crooked. Maybe you guys can just tilt your heads.
I was crooked?
Ellie did it.
It doesn't look bad. Maybe a little.
That's not bad. Here we go. Okay. Okay.
Do you need to stop?
I do, actually. All right. Okay. So here's what we're going to do. So if you look at this measurement, so I could probably say, I could put 10.0 meters. I knew the whole number of meters, we were pretty close to like the 10th of a meter. I got 10.0 meters. I'm not going to write this at 10.0000 meters because I didn't measure it that close. We struck out a tape measure. I kind of laid it on the end and said, hey, it's about 10 meters. Okay? Now, for the times, and like I said, this is the first time this has ever happened, both of you got 1.84 seconds. True? That was the number? Okay? It's never happened. Okay? Ever. You guys are just that good. Okay? Woo! Hello. So, what we're going to do to calculate this velocity is I want to take distance and I want to divide that by time. Okay? Now, we're going to use this a lot. Okay? We're going to use it a lot. And I'm going to begin to plant this seed right now. You can only do this if you have constant velocity. If you're speeding up or slowing down, I can't do this. So if I take and drop like this rubber stopper and I measure like how far it falls and I measure the time, I can't do this because that rubber stopper was speeding up as it fell. So since I was already at maximum speed when I started, why do you all laugh when I say that? I didn't say it was. Now, here's the deal. You all have to make me a promise. If y'all come back for your 20-year reunion, I'm going to be like 74 at that point. Okay? And I'm out here doing this demonstration like pushing a walker like this. All right, class, start. And I have to allocate like half of the class period for me to move 10 meters. Come to me and say, Burkamp, you fought the good fight. It's time. It's time. It's time. Where's yet? My wheelchair. Okay. Anyway. But yeah, so.
I think that's awesome.
That's easy for you to say. You're, what, 18? I'm 54. But, that's a completely different perspective on running 10 meters, sweetheart. I just put my life in my hands. Okay? I risked my life for that demonstration. Seriously. If I pulled a hamstring, I could get workman's comp for the rest of my life. Okay, anyway. So, it's a true story. All right. So, somebody get your calculators out. And somebody take 10 meters and divide that by 1.84 seconds. You do that, oh, yeah, I do have to get something to drink. Hold on. Yeah, I didn't get it. Great.
Still got it.
Okay.
Hydration.
Hydration. All right, so what did you get? Tell me what the oracle says. 5 point what?
4, 3,
Exactly?
No.
4, 7, 8, 2, 6, 0, 9.
Okay, so you get all of these numbers, okay? So here's the point. The oracle has spoken to you, and it says, here's the velocity, 5.434, whatever it is, okay? Now, this is where the door has to swing both ways. If I see this as the velocity you have for me, okay? If I have this, I'm going to think you all had phenomenal data. Like you had a laser on one end, and you had a laser on the other end, and you measured that distance out exactly, like you took the curvature of the earth into effect, okay? You had amazing data, if this is what I see as your velocity. But you don't, okay? We had some sketchy data. Guess what? We can only have a sketchy velocity, okay? So, 3 significant digits, right, because there's a decimal place. So this has 1, 2, 3 significant digits. This has 3 significant digits. Therefore, my answer can only have?
3.
So how are we going to write this? 5.43 meters per second. Beautiful. Okay? Cool. Got it. Life's good. Okay. Now, to give you some perspective, if you're, which I'm not, but if I was a world-class sprinter, okay, like world-class Olympic speed, I would have run that 10 meters in 1 second, okay? Because world-class sprinters run at about 10 meters per second. Back in the day, maybe. But typical humans, okay, typical humans will run at between 6 to 8 meters per second, okay, to give you some perspective. So again, I just tell you that so that when you begin to calculate velocities, and let's just say, hey, you know, Timmy's running the 100-meter dash, what's his velocity? And you get Timmy's velocity at like 35 meters per second? No, okay? It's not going to happen. Not going to happen. Now, if you're driving, and I'm not going to expect you to know this, I'm just giving you this as some perspective. If you're driving 70 miles per hour, that's about 30 meters per second, okay?